Hello everyone, this is Kevin Zhao, your finance professor at MTSU. One of the basic problems faced by a financial manager is how to determine today's value of cash flows expected in the future. For example, the jackpot in Powerball lottery drawing was 110 million US dollars. Does this mean the winning ticket was worth 110 million US dollars? The answer is no, because the jackpot was actually going to pay out over a 20-year period at a rate of $5.5 million per year. How much was the ticket worth then? The answer depends on the time value of the money, the subject of this chapter. In the most general cases, the phrase time value money refers to the fact that a dollar in hand today is worth more than a dollar promised at some point in the future. On a practical level, one reason for this is that you could earn interest while you waited. So a dollar today would grow to more than a dollar later. The trade-off between money now and money later depends on the rate that you can earn by doing investing. And our goal in this chapter is to evaluate this trade-off between dollars today and dollars at some future point. This is the most important chapter in this class. An understanding of time value money can be very helpful for you to understand a lot of different topics issues that we will discuss in later chapters. And your healthy knowledge, understanding of the very basic finance principle, time value of the money, will lay out a very strong foundation for you in this class. At the end of this chapter, you should be able to understand first the definition of future value and how to evaluate future value of a certain cash flow based on three different methods: by doing manual calculation based on formula, and by using your BA2 calculator, or by using Excel spreadsheet. And the second thing that you need to be able to do is understand the present value and how to calculate the present value of certain cash flows that will occur in the future. And here also you need to understand how to calculate present value based on three different methods: manual calculation, using BA2 calculator, and Excel spreadsheet. In addition, by using calculator, you should be able to calculate the rate of return on a certain investment and the number of periods that can equalize a present value future value given an interest rate. In this chapter, you will learn extensively how to calculate both future values and present values based on three alternative methods. And I want you to have a thorough understanding how to utilize each every one of those methods. The first one is using financial formulas, and the second one is use a financial calculator, typically BA2 calculator, and the third one is to use Excel spreadsheet. And here's the outline of the chapter, and we have three important topics to discuss. First one is future value and the compounding mechanism in calculating future value. And the second one is present value and the discounting mechanism in calculating present value. And the last one is we are going to learn useful techniques to solve for implied interest rates or number of periods for a typical finance problem. Now let's start with definition of both present value and future value. The present value is the current value of future cash flows discounted at appropriate discount rate. And present value is value at a time zero on a timeline. The future value, on the other hand, is the amount an investment is worth after one or more periods. It's later money on a timeline. What is the interest rate? Interest rate is the discount rate that we use in our future value or present value calculation. Right? And essentially for many businesses, interest rates means cost of capital. And for many investors, it means it's the opportunity cost of investments or opportunity cost of capital. And for most corporations, they use interest rates very intensively, because interest rate means required return for a corporation, and interest rates may have many different terminologies depending on the usage. Sometimes we call it as required rate of return, other time we call it discount rate, so on and so forth, but it depends on different scenario. Now, let's take a look at a very important tool called timeline of cash flows. Right? And I would say that before you fix any finance problem in this class, you need to draw a timeline. Right? Now let's take a look at an example of timeline of cash flow. And here we have 3-year time period. And 0 means time 0, 1 means 1 year from now, 2 means 2 years from now, and 3 means 3 years from now. So this finance problem involves 3-year time period. And for each time period, you see cash flows. CF means cash flows. CF0 means cash flow that occurs at the time 0. CF1 means cash flow occurs 1 year from now, and so on and so forth. A typical timeline will show you 3 critical information about a typical finance problem. The first one is amount of cash flows. Amount of cash flows. CF0, CF1, CF2, CF3. And those cash flow can be equal amount, and it could be uneven amount. And the second information that you can learn from a timeline is the timing of every cash flow. For example, CF1 here is the cash flow that occurs 1 year from now. And the CF3 here is cash flow that occurs in 3 years. And the last item that you will see on the timeline is that R%. What is that? That is the interest rate. Right? So from now on, for any finance problem that you need to think about, I want you to draw a timeline. Draw a timeline before you do any calculation. And drawing a timeline is very beneficial because it can show you very clearly nature of cash flows, the amount of cash flow, the timing of cash flow, and the interest rate. And here's one example for a 100 lump sum due at the end of year 2, and here you see amount of cash flow is 100. There's only one cash flow, and this cash flow occurs in 2 years. And also you see there is interest rate here, R%. Now let's look at how we can calculate the future value, and we use FV to refer to future value and PV to refer to present value. And here FV equals present value times 1 plus R raised power of T. And in this formula you see that the future value of a single cash flow equals present value times 1 plus R, which is the interest rate raised power of T. So there are 3 factors determining a future value. The first one is present value, and the second one is the interest rate, and the third one is number of time periods. And when you use your calculator, do calculation by applying this formula, I want you to know that often you will use YX function on your calculator to do the power calculation for 1 plus R raised power of T. And here Y equals 1 plus R, and the T is the X on your calculator. Now let's take a look at a very simple example in calculating future value. Suppose you invest $100 for 1 year and given 10% interest rate. What is the future value 1 year from now or in 1 year? And here when you invest $100, you know that you will receive interest, and interest equals 10% of $100. That is $10. So the value of this $100 investment in 1 year equals principal payment plus the interest that you will receive. And here principal is 100, interest is $10. So the value in 1 year equals $110. And we can apply calculation based on the formula that you see in the previous slide. The future value equals present value of $100 times 1 plus interest rate, 10% raised power of what? That will give you $110. Now let's take a look at another example. Suppose you leave the money in for another year. How much will you have in 2 years? And here we can apply the equation. FV equals present value 100 times 1 plus interest rate, 10%, that is 1.1, and raised power of 2. The answer would be $121. Now, you might have a little problem with $121 answer in the previous problem, because when you invest $100 and to receive 10% return each every year, you would say, hey, the principal is $100 and your annual interest is $10. So after 2 years, you're gonna receive $20 interest, and the future value would be $120. So why the answer is $121? And to understand why the future value 121 instead of 120, we need to understand the difference between simple interest and a compound interest. And simple interest only consider interest earned on the original principal. In a compound interest, consider a very important source of investment return, which is called interest on interest. Look, when you receive the $10 interest from your investment from the first year, what do you do with it? Most people will keep their money in your investment account and let it grow at the same interest during the second year. So the interest can be earned not only on the principal but on the interest that you receive in previous years. So here, that one extra dollar is due to the interest on the interest, which is 10% on the interest that you $10 of interest that you receive in the first year. So it generates $1 actual interest. And this is so-called a compounding interest, and this compounding mechanism should be applied in our future value calculation. Now here you see very clearly that if we apply simple interest principle, then the future value would be 120. But if we assume that investor will reinvest the interest that they receive in previous years, then we should use compounding interest. So here, one extra dollar actually comes from the interest of interest. Now let me introduce Texas Instrument BA2 Plus calculator, and this calculator is a financial calculator, and you know how to use this calculator by applying some very basic function, for example all the numbers, all the calculation symbols, so on and so forth. But the reason why this is a financial calculation, because it has some financial functionality keys, especially on the second row and on the third row. And in this class, we are going to focus on the 5 gray keys on the third row of this BA2 calculator. And I would call those 5 buttons as Five Guys. I love Five Guys, especially Five Guys burger. It's very tasty, although it looks a little greasy. What are Five Guys here? Well, Five Guys are, first one is N, which is number of time periods, and the second key here is IY, and IY is the interest for every time period. And in the middle you see PV, that is the present value, and the fourth button is FV. Of course, that means fourth key is PMT. PMT means periodic payment. And the last one is FV, of course, that is future value. Now, let me give you a little bit more details on those individual buttons on the third row of your calculator. The first one is IY. IY is the interest rate for each every time period. All right? And here's two things that you need to pay attention to. The first one is the numbers that you enter as IY. And your calculator recognize number automatically as percentage for IY. For example, if you want to enter 5% as interest rate, then you only put 5 here, not 0.05, because your calculator recognizes that 5 as 5% automatically. And the second thing that you need to be very careful is the PY, the secondary function above IY. That is the periods within 1 year. Periods within 1 year. Right? And default setting is 1. That is good. And for other calculators such as HP, the default setting could be 12, could be 4, but for HP, for BA2, default setting is 1. 1 is good. And sometimes PY was set as 4 or 12. In that case, you need to turn it back into 1. Right, so in this class, for all cash flow calculation using a BA2 calculator, I want you to make that a PY, or the secondary function above IY, as 1. Or make sure it's consistent with default setting of 1. And the fourth key here, PMT, means periodic payment between now and a future date. Since we are dealing with single cash flows in this chapter, so PMT should be set as 0. Okay, some calculators have 2 decimal points, others may have 4 decimal points, 5, 6, 7, you name it. And the more decimal points, more accurate the results is, but people don't like too many decimal points because it makes their calculator screen looks very messy. So you want to know what is the best decimal points that you need to keep on your calculator and how to change the decimal points. And here is the way that you change the decimal points on your BA2 calculator. Right? And to set a new decimal point, you need to press second point. Right? And once you do second point, actually when you do second point, you're initiating the formatting function on your calculator for decimal points. Then you enter desired decimal places. For example, 2 or 4 or 5 or 9. And 2 means 2 decimal points, 4 means 4 decimal points. And as rule of thumb, if you are calculating dollar amount, as a result, 2 decimal points would be sufficient. But if you are calculating interest rates, then 4 decimal points would be sufficient. Right? 2 is not sufficient. 2 decimal points not sufficient for calculating interest rates. You need at least 4 decimal points for that number. And some people use 9. Right? 9 decimal points is automatic decimal points. It will show the actual decimal points for any numbers. Right? Once you do second point, then enter desired decimal point, then press enter to set the displayed choice. Right. Once again, I want you to pay attention to the period per year or PY function above IY. Make sure it is 1. It is 1 because if your setting is 12 or 4, then all your future calculation will be messed up. So make sure the PY, the function above IY, is set as 1. If not, you need to set it as 1. The additional issue is about the mode of your calculator. Your calculator has a mode. I mean, not just happy or angry or sad. It's mode of beginning or mode of end. What does that mean? Well, your calculator, for most finance problems, typically you will see cash flows occur at the end of every time period. And in that case, your calculator should be on the end mode, assuming that the cash flows occur at the end of each time period. But sometimes you need to deal with problem where cash flows occur at the beginning of each time period. In that case, you need to switch. Calculator's mode from end mode to beginning mode. How to do that? Very simple. Second payment, second enter. Second payment, second enter. And when you do second payment, second enter, you are switching from the end mode to beginning mode. When you complete that operation, you will see BGM showing up at the top right of the screen. And if you wanted to switch back to end mode, you do the same thing. Second payment, second enter. Second payment, second enter. That can help you to go back and forth between the end mode and beginning mode. Now let's take a look at another example in calculating future value. Suppose you invest $100 from the previous example for 5 years. How much will you have? And to answer this question, first of all, you should try using the formula FV equals PV times 1 plus R raised to the power of T. And here, PV is 100, and R is 10% or 0.1, and T is 5. On your calculator, you should do calculation in this manner. You do not start with 100. You start with 1 plus R. So you do 1 plus 0.1. Then you press YX. YX is the power function. Then press 5. So your calculator will show 1.6105. So you do higher power calculation first. Then multiply this number with 100 to get the answer. If you start with 100, some people do 100 times 1, then plus 0.1, then raised to the power 5, then it will not give you the right answer. You needed to do higher power calculation first on your BA2 calculator. And this table showed you how every cash flows are compounded each every year. Right? And here you see interest earned has two components. First one is simple interest, $10 each every year, and also you see how interest on interest growing each every year. The interest on interest for the second year is $1, and for 30 year $2.10, for fourth year $3.31, and for the fifth year that's $4.64. And this figure showed you the interest on interest is growing over time. Initially it's basically zero, right? It's $1. You don't care about that $1 too much, but for the third year it grows up to $3.10, and for the fourth year it grow up to $6.41, and for the entire 5 years you earn $11.05 of actual interest based on interest on interest. And the second way to solve this problem is to use your calculator. Right? Remember, those 5 guys are your great friends. They can help you to fix a typical finance problem in less than 30 seconds. Right? So here, you needed to calculate FV, the fifth key. And the rule of the game is to identify 4 other guys. Once you identify 4 guys, you can capture the fifth one. And the fifth one is FV here. So what is N? N is 5. Right? And 5 means 5% because your calculator recognized as percentage. And IY is the interest rate. So you press IY, then press 10. The third one is PV, the present value. Right? And the present value is 100. It is 100. But here, your calculator is very sensitive to the direction of cash flow. So ask yourself, is this the money that you are going to receive or the money that you are going to spend? If you are spending money, it's cash outflow. If you are receiving money, that is cash inflow. So for order flow, it should carry a negative sign, and for cash inflows, it should be positive number. In this case, since you're investing money at time 0, it should be cash order flow. Therefore, you see a negative sign under the 100. And the PMT is periodic payment between now and 5 years from now, and there's nothing, so it equals 0. Then you CPT, PV. What is CPT? CPT is the first button on the first row. CPT means compute. That is a command that you're sending to your calculator. You are commanding your calculator to compute FV, and your calculator will show $161.05. And the third method is to use your Excel spreadsheet, and the Excel spreadsheet has built-in financial calculation formulas, and you can use Excel to calculate FV very conveniently. And in order to calculate FV, it requires you to put in 4 variables. First one is rate. Rate means interest rate. MPR means number of time periods. PMT is periodic payment, and PV is present value. Now let's take a look at another example to see how we can fix this problem by using 3 different methods. First one, let's look at what the problem is. Suppose you had a relative deposit, $10 at 5.5% interest, 200 years. Oh my God, 200 years ago. How much would the investment be worth today? So let's say you had an uncle of your uncle, the grandfather deposit $10 at 5% interest in a bank 200 years ago. So you want to see the future value of that $10. So on the timeline, that $10 occurs at time 0, t equals 0, and you need to calculate future value 200 years later. Right, so here PV is 10, and the interest rate is 5%, and t, number of time periods, should be 200. So it equals 10 times 1.55 raised power of 200. And the answer is $447,189.84. Right, you see how fast that $10 grew into nearly $500,000 US over the last 200 years. You can do the same calculation by using your BA2 calculator. N equals 200, IY 5.5, PV 10 or negative 10, 0 PMT, then compute FV. Right. If you put a negative sign on PV, then you will get positive sign on FV. If you put a positive sign on PV, you'll get a negative sign on FV. Right. And the third way is to use Excel spreadsheet and make sure your rate is in real number, because the spreadsheet do not automatically recognize number as percentage. So for rate, that is 0.055, number of periods 200, payment 0, and PV negative 10 means your relative or your grandfather invested $10, and today you receive a little less than $500,000 US. Now let's take a look at another problem. Suppose your company expects to increase unit sales of widgets by 15% per year for the next 5 years. If you currently sell 3 million widgets in 1 year, how many widgets do you expect to sell in 5 years? So this future value calculation can be applied to calculate something that is growing. And here something is number of widgets that a company is selling, right? And that number is growing by 15%. And let's see what will be your future widget selling number in 5 years. So PV here is 3. 3 means 3 million, and R is 15%, the rate of growing, the growth rate, and 5 here is number of years. So the answer would be 6 million. 6 million. Right. On your calculator, set N equal 5, IY equal 15, PV 3, PMT0, then you compute FV to get exact same answer. So in this chapter, you will do a lot of homework exercise to calculate either a future value or present value. And here's my suggestion. For every problem, I want you to try two different methods. First one is formula solution. The other one is calculator solution. Right? Of course, you will quickly get the answer. It's very likely a correct answer, but I want you to use second methodology to double check if your answer is 100% correct. Right? So if you use two alternative method and you are getting the exactly same number, then I can say with greater confidence that you are getting the right answer, 100% sure. Right? And double checking is very important in finance because you don't want to mess with those numbers. Now let's take a look at two very important relations in calculation of future value. And here future value is a function of present value, the interest rate, and number of time periods. So in order to have a higher future value, you either make PV greater or interest rate greater or number of year greater. So all three factors have positive relation with future value. And more specifically, the longer the time period, the higher the future value. So the longer the year that you save for your retirement plan, the more money that you will receive in the future. And the second most important relationship is relationship between interest rate and the future value. And here, if interest rate is getting higher, future value will increase. Right? Not linearly, but exponentially. And here you see the exponential growth of future value based on increase in interest rate and increase in number of time periods. And let's say you had $1 invested and you are going to invest for 10 years. If interest rate is 10%, then you are going to get a little over $2 as future value. But if your investment return increase to 20%, look, your final FV would be something above $6. So that makes a huge difference when interest rate increases. And actually you see exponential relation here. Now let's take a quick quiz before we take a break. First one, what is the difference between simple interest and compound interest? And the second one is a calculation. Suppose you have $500 invested and you believe you can earn 8% over the next 15 years. Then how much we have at the end of 15 years using compounding interest? And how much would you have using simple interest? And when we come back, we will review the answers to this quick quiz question.